This is my second video lesson for Unit 12. In this lesson, we'll be looking at how reactions at equilibrium respond to concentration changes. Go to page 6 in the class packet. Learning target. At the end of the lesson, I will be able to explain how stress in terms of concentration influences the equilibrium in a reaction. Homework B number 2, which will be a Junipod based off this lesson. Here is a system at equilibrium. Notice there's 5 fish on each side of the container. Here is the same system, but a stress is added. Notice that the equilibrium has shifted. In chemistry, here are some stresses for chemical reactions: concentration, pressure, temperature, and volume. In this lesson, we'll be focusing on the concentration stress. In the next lesson, we'll be focusing on the pressure and temperature stress. In order to understand how stress can affect a system at equilibrium, we'll be talking about Chatellier's principle, which is if a stress is added to a system at equilibrium, the reaction will shift to remove the stress and restore equilibrium. If we look at this example over here, initially we have a system at equilibrium. Whether we add water or remove water, we disrupt the system, and the system will work to restore equilibrium. Take a moment to watch a video about Chatellier's principle on concentration. Once you watch the video, resume this one. In order to figure out how changing the concentration, whether increasing or decreasing the concentration, will affect equilibrium, we'll be using the balance beam method. So first, draw a balance beam with products and reactants on each side and make sure it's balanced on both sides. So notice I have one box on the reactant side and one box on the product side. It is balanced. We'll be using the balance beam method to predict where would the equilibrium shift and how it will be restored. Let's look at the first example. An increase in the concentration of A will cause the reaction to shift towards what? So here is our reaction at equilibrium. A and B are the reactants, C and D are the products. The stress that's added to this reaction is the increase in the concentration of A. Whenever you see the words shift towards, it means to make more. So by increasing the concentration of A, it will cause this reaction to make more what? Which substance in the chemical equation will be produced in order to restore equilibrium? Since A is a reactant in the chemical equation, we're going to add a box to the reactant side in the balance beam. This will cause the balance beam to tilt over. We can clearly see that increasing the concentration causes imbalance for a reaction at equilibrium. Therefore, in order to restore equilibrium, we need more products. So the reaction is going to produce more products to restore equilibrium. So an increase in the concentration of A will cause the reaction to shift towards or make more products. So why does this happen in terms of the collision theory? Addition of A will cause more collisions to make more products, which increases the rate of the 4 reactions. Since we're adding more A, it's more likely for A to collide with B to make more of the products. Let's look at question 2. A decrease in the concentration of B will cause the reaction to shift towards what? We're first going to draw a balance beam. Since B is a reactant and we're decreasing it here, we're going to remove the box in the reactant side. This will cause the balance beam to tilt. Now we can clearly see how we can make the balance beam balance again. We need more reactants. Therefore, the reaction is going to shift towards the reactant side. So a decrease in the concentration of B will cause the reaction to shift towards or make more reactants. So why does this happen? The equilibrium shifts to the left. Removing B disrupts the equilibrium. Thus, the system must shift to make more reactants from the products. Learning check number 1. Given the reaction at equilibrium, if the concentration of O2 on the system is increased, the equilibrium will shift towards what? Pause the video and resume once completed. Since O2 is a reactant, we're going to add a box on the reactant side. So in order for equilibrium to be restored, we need to increase or make more products. So shift right. In learning check number 2, the concentration of O2 is increased. What will happen to the concentration of CO2? Pause the video and resume once completed. From the previous learning check, the reaction will shift right. Since CO2 is on the right side of the chemical equation, is on the product side, it will increase. Learning check number 3. If the concentration of O2 on the system is decreased, the equilibrium will shift towards what? Pause the video and resume once completed. Let's use the balance beam method. Since O2 is a reactant and is decreasing in the system, we are going to remove one box from the reactant side. So in order for equilibrium to be restored, more reactants have to be made. So the answer is choice 1, left. Learning check number 4. If the concentration of O2 on the system is decreased, the concentration of H2O would do what? Pause the video and resume as completed. From the previous learning check, when O2 decreases in the system, it shifts towards the left side, which is the reactant side. Since H2O is on the product side, it will decrease. Learning check number 5. If the concentration of O2 on the system is decreased, the concentration of HCl would do what? Pause the video and resume as completed. Since O2 is decreasing in the system, from the previous learning check, it will shift left on the reactant side. Since HCl is on the reactant side, it will increase. Choice 2. Here's a summary slide of what we talked about. Increasing the concentration on one side shifts to the other side. Decreasing the concentration on one side shifts to the same side. Try to finish the rest of the questions on page 6 on your own. Pause the video and resume once completed. Here are the answers. Learning check number 6. Given the reaction, which change would cause an immediate increase in the rate of the forward reaction? Pause the video and resume once completed. In order to increase the rate of the forward reaction, we need to add more reactants. So the answer is choice 2. By adding more reactants, it will favor the product side. Learning check number 7. Given the reaction at equilibrium, increasing the concentration of N2 will increase the forward reaction rate due to what? Pause the video and resume as completed. The answer is choice 2 because by adding more N2, there will be more effective collisions. Let's look at more practice questions on page 7 in the class packet. In question 1, we're given a reaction at equilibrium. Predict where the equilibrium will shift, where the stress is added, and how the concentration will change. Let's look at the first stress. Here we're increasing the concentration of N2. Since N2 is a reactant, by adding more reactant, it will shift to the opposite side, which is the product side. H2, which is on the reactant side, will decrease because we're favoring the product side right now. NH3 is a product, therefore it will increase. Let's look at the next one. Here we're decreasing N2. Since N2 is on the reactant side, by decreasing it, we'll shift to the same side. So we're favoring the reactant side. Since H2 is on the reactant side, it will increase. NH3 is on the product side, but we're favoring the reactant side, therefore it would decrease. In the next one, we're increasing the H2 concentration. Since H2 is a reactant, by adding more H2, we're favoring the opposite side, which is the product side. Since N2 is on the reactant side, it would decrease. NH3 is on the product side, therefore it will increase. In the last one, we're decreasing the concentration of NH3. Since NH3 is on the product side, by decreasing it, we'll shift to the same side, which is the product side. Since N2 and H2 are on the reactant side, they would decrease in the concentrations. Let's look at question 2. Here we're given a saturated solution of silver chloride. Let's look at the first stress. We're increasing the chloride ion. Since chloride ion is on the product side, if we add more of it, it'll shift to the opposite side, which is the reactant side. Since silver chloride is on the reactant side, it will increase. Silver ion, which is on the product side, will decrease. In the next stress, we're decreasing the silver ion. Since silver ion is on the product side, it will shift to the same side, which is the product side. Since silver chloride is on the reactant side, it is not favored, therefore it will decrease. Since chloride ion is on the product side, it will increase. The next stress is increasing silver chloride. Since silver chloride is on the reactant side, by adding more, we can shift to the opposite side, which is the product side. Since silver ion and chloride ion is on the product side, it will increase. The next stress is adding NaCl. Notice that NaCl is not anywhere in this equation. So let's analyze what will happen. So what will happen when NaCl is added to a saturated solution of AgCl? So in a saturated solution, there is water, and NaCl will dissolve. So NaCl will dissociate into ions. So what is the common ion between NaCl and silver chloride? So the common ion is chloride ion. So basically, when we add NaCl, we're basically adding chloride ions. What will happen to a silver chloride when NaCl is added? Why does this happen? When we add NaCl, we're basically adding chloride ions. And since chloride ion is on the product side, when we add it, it will shift to the opposite side, which is the reactant side. And since AgCl is on the reactant side, it will increase. Since silver ion is on the product side, it will decrease because it's combining with chloride ions to make more silver chloride. What will happen to the solubility of AgCl with the addition of the common ion? Since silver chloride solid is being formed, solubility is decreasing because it is precipitating. This is known as the common ion effect. In saturated ionic salts, addition of another ionic compound with a common ion causes a decrease in the solubility of the saturated ionic salt. Let's look at this example. Here we have a solution of a saturated silver chloride. We have solid silver chloride at the bottom of the container. When we add sodium chloride, the common ion is chloride ions. It will cause more silver chloride to precipitate and form, and the silver ion concentration will decrease. Learning check number 8. When NaCl is added to a system, the equilibrium will shift to the what? Pause the video and resume as completed. When we add NaCl, we're basically adding chloride ions, so the equilibrium will shift to the left, which is the opposite side. Silver ions will decrease since it's on the right side. Answer is choice free. Learning check number 9. Which substance, when added to the mixture, will cause an increase in the amount of barium chromate solid? Pause the video and resume once completed. So we want the equilibrium to shift left, so we need a common ion, a barium ion, or chromate ion. So the best answer is choice 3, barium chloride. The common ion in this case is barium ion. Try to do the rest of the questions on your own. Pause the video and resume as completed. Here are the answers. This concludes the video lesson. Remember to do the Junipod homework.